What if your emergency light was smart enough to turn on by itself during power cuts? Charge automatically, power your USB devices, and protects its battery with a smart charger that actually extends its life, something regular emergency lights just can't do. And the best part, it's 100% automatic. Introducing the ultimate DIY emergency light, 10,000 mAh battery, USB output, smart automatic charging, all powered by a tiny 8-pin PIC microcontroller. And yes, you can build this too. So what does it actually do? The moment mains power goes up, this light turns on automatically. You can power any 5V USB gadget straight from the built-in port. The smart charger starts and stops charging automatically, keeping your battery healthy and extending its lifespan. It constantly monitors battery voltage and shows clear indicators. Red LED lights up if the battery is extremely low. This works only when connected to mains because they are powered from the wall, not the battery. You also get full manual control. Adjust brightness, choose which LED panel turned on during a power cut, toggle USB output with a button, and even force it into charging mode, helpful during battery replacements. Let's talk about the tech behind it. At the heart of the system is the PIC 12F675 microcontroller. Just 8 pins, but it does a lot. Monitor battery voltage, control the relay, drives the LED indicators, makes all the smart decisions. Here's how it works. A simple voltage divider sends half the battery voltage into the MCU ADC input. The software compares that with the threshold and turns the charger on or off using a relay controlled by a transistor. The charger is minimal, rectified DC, 2 resistors to limit current to C/10, total capacity divided by 10, or 1 ampere in my case. To make the reading accurate, I used an LM317 to generate a tunable 5V reference. Since the ADC uses VCC as reference, any voltage drift can ruin accuracy. This fixed 5V ensures reliable ADC data, so the microcontroller knows exactly when to stop or resume charging. Before inserting the MCU, always set the LM317 output to exactly 5V using a multimeter. Too low is gonna give you wrong readings, too high, you might damage the chip. This build runs on a 10,000 mAh 6V battery pack. That's 2 6V 5H SLA batteries in parallel. And all it takes are few components: LM317, LD117, relays, diodes, and bunch of resistors, and some clever code. I built this to solve a real problem. Most commercial emergency lights are poorly built. They overcharge batteries, use plastic cases that crack in an ear, and give you zero control. With this DIY project, you get full control over the system, and it's open source. You can learn from it, customize it. All the schematics, calculations, and firmware are in the GitHub repo. If you believe in tech, that actually makes life better. Subscribe, because I am a multidisciplinary engineer.